So for our next video, we're going to go over some old geometry topics that you've seen before, just so that we get back used to them so we can use them in this next unit. So to begin with, we're going to talk about finding the length or the distance between points and then finding the midpoint. Alright, so we got to adjust our sizes here. Alright, and then this A got split up, and that's a -2. Alright, so the distance formula you should have memorized. You've seen it before, and if you don't have it memorized, memorize it now. But that's that big square root function, alright? So it's distance equals the square root, and then in parentheses, x2 minus x1 squared, plus parentheses y2 minus y1 squared. And this comes from the Pythagorean theorem, where you have a squared plus b squared equals c squared. So then to get c, you take the square root of the other side. Alright, so we have to find the distance between our x's and square it, the distance between our y's and square it, and then take the square root of the whole thing. So for this one, right, we got x1, y1, x2, y2. Alright, so then we've got the square root, first parentheses, -4 minus a -2 squared, plus a 4 minus a -3 squared. Now order matters because it's subtraction, but it doesn't necessarily matter which x you start with, as long as the x that you start with is the y that you start with. So if I started with a -2 in the first parentheses, I would start with a -3 in the second. Okay, so if I minus a negative, that's going to become plus. So -4 plus 2 becomes -2. And then the same thing here, 4 plus 3 becomes 7. And then 2 squared is 4. 7 squared is 49, and then 4 plus 49 is 53. Okay, we will need to try to simplify our radicals, but 53, we don't have anything that goes into it, so it's going to stay the square root of 53. For the second example, I've got J and K and L, and I want to know if JK is congruent to KL. So remember, congruent is same shape, same size, so I've got to see if their distances are the same. Alright, so I'm going to do JK over here, and whenever we're talking about distance, we take off that segment bar. So it's no longer a segment, we're talking about the length of JK. Alright, and then we got the big square root. Alright, so I'm going to start with 3 for my x. So I'm going to do 3 minus the -1. Alright, plus, and because I started with 3, I've got to start with -5 for my y, and that's -2. Alright, 3 minus -1 is 3 plus 1. So that's 4 squared, plus -5 minus 2 is -7. So 4 squared is 16. -7 squared is 49. Right, 16 plus 49 is going to give us 65. Because I'm just looking to see if they're congruent, I'm not going to worry about simplifying that, because all I need to see if it's square root of 65 and square root of 65. Alright, so I'm going to do the same thing, but now I'm going to do it for KL. Alright, so I'm going to start with -1 minus -5 squared, and then I have to start with 2 minus -5 squared. Alright, -1 minus negative is -1 plus 5, which is 4. And then 2 minus -5 is 2 plus 5, which is 7. 4 squared is 16, 7 squared is 49, which gives us the square root of 65. So yes, JK is congruent to KL because they're both root 65 units long. Alright, finding the midpoint. Okay, your midpoint is obviously a coordinate point because it's a midpoint. Right, and to find it, we take the average of our x's and the average of our y's. So our midpoint, we have parentheses, is x plus x divided by 2, comma, y plus y divided by 2. Alright, and order does not matter when you add, so it doesn't matter which x goes first or which y goes first. All that matters is that you add them together. Alright, so for this one, I want to find the midpoint for A and B. Alright, so A is at 10, B is at -2, 5. So for my x's, I'm going to have 10 plus -2 divided by 2. Then for the y's, 8 plus 5 divided by 2. Well, 10 plus negative is 10 minus, so 10 minus 2 is 8. So we have 8 over 2, and then 8 plus 5 is 13. I can simplify 8 over 2 to 4. I cannot simplify 13 over 2, so I'm just going to leave it as 13 over 2. For example 4, I've got a negative 12 and 2, and a negative 9 and 10. So negative 12 plus 2 is negative 10, and negative 9 plus 10 is 1. Negative 10 over 2 can be simplified to negative 5, and then 1/2 can't, so we'll leave it as 1/2. All right, now I'm given the endpoint of a segment and the midpoint, and I want to find the coordinates of the other endpoint. So I've got to work backwards a little bit. Remember, my formula is that I add the x's and divide by 2, add the y's and divide by 2. So for this first example, I know A, right, and I'm looking for B. So we'll call B x and y. So when I go to plug in my formula, I have negative 5 from A plus the x of B divided by 2, and then the 9 plus the y of B divided by 2, and that ends up giving me negative 8, negative 2, because that's my midpoint. Okay, so that means that this part over here, let's make that bigger, this part over here has to equal negative 8, and then this part has to equal negative 2. So I have two equations that I can write. So the first one is negative 5 plus x divided by 2 equals negative 8. All right, and then the second one, which will come up here, 9 plus y over 2 equals negative 2. So for both of these, the first step for solving for x and y is going to be to multiply by 2, get rid of that fraction. So we get negative 5 plus x equals negative 16. And then up here, 9 plus y equals negative 4. Then to get x by itself, I'm going to add the 5 over. So x equals negative 11. And then subtract the 9. So y equals negative 13. So then that means that the point B is at x negative 11, y negative 13. All right, example 6 is the same way. So I'm going to jump straight to my equations. All right, so again, B is going to be x and y for now. So I have 6 plus the x of B divided by 2 has to equal the x of my midpoint. And we've got 7 plus the y of B divided by 2 has to equal the y of my midpoint, negative 7. So we multiply by 2. So we get 6 plus x equals 20, and subtract 6. So then x equals 14. Multiply by 2. 7 plus y equals negative 14. Subtract 7. Y equals negative 21. So then my point B is at 14, negative 21. All right. We also have to talk about parallel and perpendicular. Okay, so remember, parallel lines never touch. They're always the same distance apart. And perpendicular lines intersect at a right angle, so at that 90-degree angle. All right, the stuff we know about parallel and perpendicular when we're looking at their equations is that parallel lines have the same slope. Okay, perpendicular lines have a slope that are opposite reciprocals. So the opposite is talking about the sign. Right, so that means that if it was negative, now it's positive, or vice versa, and the reciprocal means you flip your fraction. So if I look at example 7, I want to know if these lines are parallel, perpendicular, or neither. Well, one of the easiest ways to look at it is to look and see, or put them in slope-intercept form so you can look at their slopes very easily. So remember, slope-intercept form is y equals mx plus b. So for this first one, I'm going to subtract the 3x, so we get 5x equals negative 3x plus 10, and then divide everything by 5. I don't even have to worry about simplifying because I can see the negative 3/5 there. Over here, I'm going to subtract the 5x, so we get negative 3y equals negative 5x minus 6, divide by negative 3. All right, and here's my slope, which ends up being a positive 5/3 because the negatives cancel. So for this one, I go from negative 3/5 to positive 5/3. So I have the opposite sign, flip my fraction, so these are perpendicular. All right, for the second one, same thing. I'm going to subtract the 2x, so I get 7y equals negative 2x minus 35. Then divide by that positive 7. So my slope for the first one ends up being negative 2/7. All right, for the next one, I subtract the 4x, so we get 14y equals negative 4x minus 42. Then divide by the 14, so I end up with negative 4 over 14, which simplifies to negative 2 over 7. So I have negative 2 over 7, negative 2 over 7, so these lines are parallel. So for example 8, I just want to find the slope, which we can eventually use to see if lines are parallel or perpendicular. So to find the slope is the change in y over the change in x, so y2 minus y1 over x2 minus x1, or rise over run. Because of subtraction, order matters, so whatever y we start with is the x that we have to start with. So for the first one, if I start with the 5, I'm going to do the 5 minus the negative 7 over, I started with 5, so I have to start with negative 4 minus 2. So a minus a negative becomes plus. 5 plus 7 is 12. Negative 4 minus 2 is negative 6. 12 divided by negative 6 is negative 2. For number 2, if I start with a 10, we have 10 minus 8 over the 5 minus negative 2. 10 minus 8 is 2. Minus a negative becomes plus. 5 plus 2 is 7, and I can't simplify that. Alright, and then for example 9, I want to write the equation in the slope-intercept form, so that's mx plus b, for the line that passes through 3, negative 2, and is parallel to the graph of y equals 3x plus 5. So to start with, I'm going to look at 3x plus 5, and I see that my slope is 3. A parallel line has the same slope, so that means my new slope is going to be 3. So I have y equals 3x plus b. Now I have to find this y-intercept using this point 3, negative 2. So I'm going to temporarily plug these in as x and y to figure out what b is and then rewrite my equation. So I've got y is negative 2 equals 3 times x is 3 plus b. So that's negative 2 equals 9 plus b, subtract 9. So then b equals negative 11. So y equals 3x minus 11. Right, then for example 10, I want to write the equation that's perpendicular to this graph with a slope of 1/3 and goes through negative 4, 5. So the opposite reciprocal of positive 1/3 is going to be a negative 3 over 1, or just a negative 3. So I have y equals negative 3x plus b. Right, then I've got x and y here to plug in, so 5 equals negative 3 times negative 4 plus b. Then negative 3 times negative 4 is positive 12. Subtract 12, so we get b equals negative 7. So then my equation is negative 3x minus 7.